Dad, where's my jacket?
I don't know.
I have an alternative. So cold. Maybe I should try flipping the foil around.
What are you doing, Jana?
Just my jacket, so as an alternative I used tin foil and I put the dull side on my body first. So once I got outside, it was still cold. Do you think using the shiny side towards my body would work any better?
Huh, that's an interesting question. So if we kind of like bring it all together, the real question is, what side of the foil would keep you warmer if you were going outside? But in other words, if we were to bring it down to a smaller scale, what side of the foil would keep you warmer if you were wrapping a burrito?
I think the shiny side would work better because the heat will affect off the shiny side inside the burrito.
Let's try doing an experiment on it. We're going to need some foil, obviously. We're going to use two different types so we have accurate data. We're going to need a microwave, a burrito, the LabQuest at school, the thermometers that hook up to the LabQuest, and an iPad. So first thing we're going to do is take the burrito and we're going to put it on a plate and we're going to heat it for exactly 1 minute in the microwave. Then we're going to take it out, wrap it up in the foil. Depending on which side we're testing, it'll either be dull side in or shiny side in facing the burrito. After 5 minutes of letting the burrito sit, we're going to then plug the thermometer that's hooked up to the LabQuest into the burrito. Then we're going to record for 5 minutes. Then we will get our data. For each type of foil and each side, we will do it twice. So let's say we have our heavy duty foil on the shiny side, we'll do two trials of that. And after we collect our data, we'll be able to find the slope using the iPads, which will tell us which side of the foil, decreases faster or slower. Woo! That's hot!
Oh, this thing's hotter than the Peyton Manning at the Super Bowl.
So after doing this experiment, we got our data, we took everything, we averaged everything out, and after doing all of this, our first foil, using the shiny side, had an average of negative 0.23 degrees per minute. So that means per every minute, it went down 0.23 degrees. For the dull side, or you could also call it the matte side of that foil, we had an average of negative 0.7 degrees per minute. So decreased at 0.7 degrees per minute. For our second kind of foil, on the shiny side, we had a decrease of 0.124. And for the matte side, we had a decrease in 0.049. So if we're looking at all the data, the shiny side of the first foil decreased slower than the matte side. But if you look at the second foil, the shiny side decreased faster than the dull side.
Does that mean no matter which side of the foil we use, the burrito won't stay warmer on either side?
Yes, that's absolutely right, Jana. So, neither the matte side nor the shiny side makes a difference on holding heat. We hypothesized before that the shiny side would hold in heat better, but that was incorrect. We learned from the data that here we have the shiny side of an average of 0.23 decreasing, contrasted with the other brand of foil, which decreased at 0.124. And then with the matte side of the first kind of foil, it decreased at a 0.539 decrease, and the next foil decreased at 0.049. So in the first foil, the shiny side decreased a little bit slower, and the second foil, the shiny side decreased faster. Therefore, we can come to the conclusion that it doesn't matter what side of the foil you use, it only matters, if you think about it, how tightly you wrap it and how many layers of foil you use.